Dear children, now let us solve 3 marks question of the LBA of the Introduction to Trigonometry. Now you take the 79th question. Prove that sin A by 1 minus cot A plus cos A by 1 minus tan A equals sin A plus cos A. Here you take the LHS. LHS equals sin A by 1 minus cot A plus cos A by 1 minus tan A equals, in the first step, express cot in terms of cos by sin and tan in terms of sin by cos. Write sin A as it is. In the denominator, 1 minus cot A is 1 minus cos by sin, 1 minus cos A by sin A, plus cos A by 1 minus tan A is sin A by cos A. That equals, write the sin A as it is, and in the denominator take the LCM. What is the LCM? LCM is sin A. So you write sin A, and what the numerator becomes here? 1 is to be multiplied by sin A. 1 into sin A is sin A, and write this cos A as it is. Plus, here 1 means 1 by 1. 1 into sin A is sin A. Therefore, 1 into sin A we have to take sin A here. Here also, write cos A as it is, and the LCM is cos A, and the numerator becomes cos A minus sin A. Cos A minus sin A equals, here you take the reciprocal for this sin A minus cos A by sin A. You write sin A into sin A by sin A in minus cos A. Sin A minus cos A plus here also, if you take the reciprocal of cos A minus sin A by cos A, it becomes cos A into cos A by cos A minus sin A equals, sin A into sin A is sin square A by sin A minus cos A. Sin A minus cos A. Here you observe, in this part, sin A minus cos A is in the denominator, but here cos A minus sin A is there. So you must have same sin A minus cos A here. In that case, what happens? This plus sign becomes minus sign. You know that cos A minus sin A, that is minus sin A plus cos A, that is minus sin A plus cos A. To have minus sign here, as in the sin A minus cos A, we have to take minus outside. In the bracket, it becomes sin A minus cos A. So this minus we have taken here. Therefore, this plus cos A by cos A into cos A by cos A minus sin A is same as minus cos square A by sin A minus cos A. Here sin A minus cos A is there. Here also we got sin A minus cos A by changing the plus into minus and interchanging sin A and cos A. The next here, see, sin A minus cos A is there, sin A minus cos A is there. Take it as a LCM. Sin A minus cos A. The denominators remains as it is because both of them are having sin A minus cos A in the denominator. Therefore, you write sin A minus cos square, sin square A minus cos square A as it is. So, write sin square A minus cos square A. Here, sin square A remains sin square A only, cos square A remains cos square A only because the denominators are same. Denominators are same. Equals. This is in the form of a square minus b square. Sin square minus cos square is in the form of a square minus b square. And the factors of a square minus b square are a minus b into a plus b or a plus b into a minus b. So, write its factors a plus b into a minus b or a minus b into a plus b. Write sin A plus cos A plus b into a minus b, sin A minus cos A by sin A minus cos A. Here sin A minus cos A, sin A minus cos A, from the numerator and denominator cancels. Then what is remaining? Only sin A minus cos A is remaining. Then you write that is equals to sin A plus cos A. Sin A plus cos A is remaining. That is equals to RHS. Therefore, you write, what is that? Sin A by 1 minus cot A plus cos A by 1 minus tan A is equals to sin A plus cos A. Sin A by 1 minus cot A plus cos A by 1 minus tan A is equals to what? Sin A plus cos A. Sin A plus cos A. Question number 80. Prove that 1 plus cos A by sin A minus sin A by 1 plus cos A is equals to 2 cot A. Take the LHS. LHS equals 1 plus cos A by sin A minus sin A by 1 plus cos A, sin A by 1 plus cos A equals, here you take the LCM. LCM is the product of the sin A and 1 plus cos A. Let us write the LCM. Sin A into 1 plus cos A is the LCM. 1 plus cos A. Now in the numerator, 1 plus cos A is to be multiplied by 1 plus cos A and sin A is to be multiplied by sin A because the product of these two is the LCM. Then you write sin A into 1 plus cos A into 1 plus cos A is 1 plus cos A whole square. 1 plus cos A whole square minus sin A into sin A, sin square A. Sin square A equals expand 1 plus cos A whole square by using the identity A plus B the whole square equals A square plus 2AB plus B square. A square is 1 square plus 2AB. 2AB is 2 into 1 into cos A. Cos A plus cos square A plus cos square A minus sin square A by sin A into 1 plus cos A. Then write 1 square as 1 plus 2 into 1 into cos A is 2 cos A plus cos square A minus sin square A by sin A into 1 plus cos A equals, write the denominator as it is, sin A into 1 plus cos A. Then here what you have to prove? You have to prove that 2 cot A. In the place of 1, write sin square A plus cos square A. Sin square A plus cos square A. You know the identity that sin square A plus cos square A is equals to 1. Therefore, in the place of 1, you write sin square A plus cos square A. And you write 2 cos A as it is minus cos square A minus sin square A as it is. Not minus, plus cos square A minus sin square A. Then here sin square A and minus sin square A cancels. Then write 2 cos A plus cos square A plus cos square A is 2 cos square A. 2 cos square A. Write the denominator as it is. Sin A into 1 plus cos A equals, here you can remove 2 cos A common, remove that outside, 2 cos A, here 2 is there, and cos A plus cos square A is there. So you can remove 2 cos A as a common, write it outside. In the bracket what is remaining? 2 cos A is outside, 1 is remaining here. 2 cos A into 1 is 2 cos A. Then write plus 1 plus, here what is remaining? Only cos A. 2 into cos A is 2 cos square A. So you got in the bracket 1 plus cos A. Then you write sin A into 1 plus cos A as it is. You can cancel this 1 plus cos A and 1 plus cos A as they are in the numerator and denominator. Then you got 2 cos by sin. Cos by sin is cot. 2 cot A, which is equals to RHS. Therefore, you can write 1 plus cos A by sin A minus sin A by 1 plus cos A is equals to 2 cot A. Right? 1 plus cos A by sin A minus sin A by 1 plus cos A equals 2 cot A. Question number 81. Prove that 1 plus sin A by cos A minus cos A by 1 plus sin A is equals to 2 tan A. This is the question same as question number 80. Here only change is cos A and sin A are interchanged and cot A and tan A are interchanged. Same methods we have to follow here. Same steps are to be followed. So then you write the LHS first. What is LHS? LHS equals 1 plus sin A by cos A minus cos A by 1 plus sin A equals, here also take the LCM. What is the LCM? The product of these two becomes the LCM. That is cos A into 1 plus sin A. Then in the numerator, what you are going to get? 1 plus sin A into 1 plus sin A. 1 plus sin A whole square minus cos A into cos A, cos square A equals, write the denominator as it is, cos A into 1 plus sin A. Expand 1 plus sin A whole square by using the identity A plus B the whole square equals A square plus 2AB plus B square. Then A square is 1 square plus 2AB is 2 into 1 into sin A plus B square. B square is sin square A. And you write minus cos square A as it is. The next, write the denominator as it is, cos A into 1 plus sin A. 1 square is 1 plus 2 into 1 into sin A is 2 sin A. Write plus sin square A minus cos square A as it is equals, write the denominator as it is, that is cos A into 1 plus sin A. In the place of 1, write sin square A plus cos square A. And write 2 sin A as it is plus 2 sin A plus, write sin square A minus cos square A as it is, sin square A minus cos square A equals cos A into 1 plus sin A. Now cos square A minus cos square A cancels. Then you write 2 sin A. What is remaining here? 2 sin A plus sin square A plus sin square A is 2 sin square A. 2 sin square A equals cos A into 1 plus sin A. Here you can remove 2 sin A common. Remove that outside. And in the bracket what is remaining? In this term what is remaining? 1. Plus here 2 sin A is outside. What is remaining? Sin A is remaining. So 2 sin A into 1 is 2 sin A. 2 sin A into sin A is 2 sin square A. Now you can cancel 1 plus sin A, 1 plus sin A as they are in the numerator and denominator. Then it becomes 2 into sin A by cos A is tan A. equals RHS. Therefore, you can write 1 plus sin A by cos A minus cos A by 1 plus sin A is equals to 2 tan A. Right? 1 plus sin A by cos A plus cos A by 1 plus sin A is equals to what? 2 tan A. Then question number 82. Prove that cos theta minus 2 cos cube theta by 2 sin cube theta minus sin theta is equals to cot theta. Write the LHS. Equals cos theta minus 2 cos cube theta by 2 sin cube theta minus sin theta equals, here cos theta is there, 2 cos cube theta is there, you can remove cos theta common, write it outside in the bracket. Here what is remaining? Cos theta is outside, so 1 is remaining, minus here 2 cos cube theta is here. What is remaining in the bracket? As cos theta is outside, you know that cos theta into cos square theta is cos cube theta. Next, here remove sin theta as a common, that is equals to 2 sin square theta is remaining in 2 sin cube theta, because sin theta is outside. Sin theta into 2 sin square theta is 2 sin cube theta, and minus here what is remaining? 1, because sin theta into 1 is sin theta. Then write cos theta as it is. In the place of 1, write sin square theta plus cos square theta minus 2 cos square theta and you write sin theta into 2 sin square theta minus, in the place of 1 you write sin square theta plus cos square theta. Here as minus sign is there, we must write that sin square theta plus cos square theta in the bracket. That equals cos theta into, write sin square theta as it is, cos square theta minus 2 cos square theta is minus cos square theta by, write this sin theta as it is, into, write 2 sin square theta, open the bracket here, it becomes minus sin square theta minus cos square theta minus sin square theta minus cos square theta equals, write cos theta into sin square theta minus cos square theta as it is. In the denominator, write sin theta as it is. 2 sin square theta minus sin square theta is sin square theta and minus cos square theta. Minus cos square theta equals sin square theta minus cos square theta. Sin square theta minus cos square theta are in the numerator and denominator cancels. Cos by sin is cot theta, which is equals to RHS. Therefore, you can write cos theta minus 2 cos cube by 2 sin cube minus sin theta is equals to cot theta. Therefore, cos theta minus 2 cos cube theta by 2 sin cube theta minus sin theta is equals to cot theta. Question number 83. Prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equals to tan theta. This is same as the question number 82. The solution steps are same. Now you write the LHS. LHS equals sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta equals, here you remove sin theta as a common, remove that outside. Sin theta is common, remove that outside. In the bracket, here what is remaining? 1 is remaining. 1 minus 2 sin square theta. Here cos theta is common, remove that outside. Cos theta into, here what is remaining? 2 cos square theta minus 1 equals, write sin theta as it is. In the place of 1, write sin square plus cos square. Sin square theta plus cos square theta minus 2 sin square theta. Here cos theta into, write this 2 cos square theta as it is, 2 cos square theta minus, in the place of 1 write cos sin square theta plus cos square theta. Sin square theta plus cos square theta. Equals sin theta by cos theta into, here it is sin square theta, right, here cos square theta, cos square theta, sin square theta minus 2 sin square theta is minus sin square theta. Here you open the bracket, write 2 cos square theta as it is minus sin square theta minus cos square theta. If the bracket is opened, the sign changes. Then sin theta by cos theta into numerator, write numerator as it is, cos square theta minus sin square theta. Here 2 cos square theta minus cos square theta is cos square theta minus sin square theta equals cos square theta minus sin square theta, cos square theta minus sin square cancels. Sin by cos is tan, sin theta by cos theta is tan theta, which is equals to RHS. Therefore, we write that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equals to tan theta. So, we write sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equals to what? Tan theta. Question number 84. Prove that sin A minus cos A by sin A plus cos A plus sin A plus cos A by sin A minus cos A equals 2 by 2 sin square theta 2 sin square A minus 1. What is that question? Sin A minus cos A by sin A plus cos A plus sin A plus cos A by sin A minus cos A is equals to 2 by 2 sin square A minus 1. Write the LHS. LHS equals sin A minus cos A, sin A minus cos A by sin A plus cos A plus sin A plus cos A by sin A minus cos A by sin A minus cos A equals, here take the LCM. The LCM becomes the product of these two, sin A plus cos A into sin A minus cos A. In the denominator, write the LCM. The LCM becomes product of these two. And you write sin A plus cos A in one bracket. In the other bracket, sin A minus cos A. Sin A plus cos A into sin A minus cos A. Then the numerator becomes, the sin A minus cos A must be multiplied by sin A minus cos A. So it becomes sin A minus cos A whole square. Sin A minus cos A into sin A minus cos A is sin A minus cos A whole square. Plus this also, sin A plus cos A into sin A plus cos A becomes sin A plus cos A whole square. Sin A plus cos A whole square. Write the product of sin A plus cos A into sin A minus cos A is sin square A minus cos square A. Here we have to use the identity A plus B into A minus B, that is A square minus B square. So sin square minus cos square A, sin square A minus cos square A. Right, sin A plus cos A into sin A minus cos A is sin square A minus cos square A. Sin square A minus cos square A, that is A plus B into A minus B is A square minus B square. It becomes sin square A, which is A square, cos square A, which is B square. A square minus B square is nothing but here sin square minus cos square. Then write the expansion of sin minus cos A whole square by using the identity A minus B the whole square equals A square minus 2AB plus B square. A square is here sin square A. sin square A minus 2ab is 2 sin A into cos A plus cos square A, that is B square. And the expansion of sin A plus cos A whole square is, by using the identity A plus B the whole square equals A square plus 2ab plus B square is A square. A square is sin square A. 2ab is 2 into sin A into cos A plus B square. B square is cos square A. A square plus 2ab in plus B square. Now, here the denominator is 2 sin square A minus 1. Therefore, you express this cos square A in terms of sin square A. Write sin square A as it is. Minus cos square A is 1 minus sin square A. Cos square A is 1 minus sin square A. Now, in the numerator, write sin square plus sin square together, that is 2 sin square A. Similarly, cos square plus cos square together 2 cos square A. Then you write 2 sin square A plus 2 cos square A minus 2 sin A into cos A plus 2 sin A into cos A cancels, equals, open the bracket in the denominator, write sin square A as it is, minus, it becomes minus 1, minus of minus plus sin square A. Here you remove 2 common. In the bracket, write sin square A plus cos square A plus cos square A equals, sin square A plus cos square A is 1. Write 2 into 1 by sin square A plus sin square A is 2 sin square A and minus 1. Minus 1 equals 2 into 1 is 2. 2 by 2 sin square A minus 1, which is equals to RHS. Therefore, sin A by sin A plus cos A plus sin A plus cos A by sin A minus cos A is equals to what? 2 by 2 sin square A, 2 sin square A minus 1. Question number 85. If x equals p tan theta plus q secant theta and y equals p secant theta plus q tan theta, then prove that x square minus y square equals q square minus p square. Now you write what is given here. Take x equals p tan theta plus q secant theta and y equals p secant theta plus q tan theta. Then you take x square minus y square. Here x square is p tan theta plus q secant theta whole square. P tan theta plus q secant theta whole square minus y is p sec theta plus q tan theta whole square. P secant theta plus q tan theta whole square. Expand both by using the identity a plus b the whole square. P tan theta is a and q secant theta is b. That is a plus b the whole square is a square plus 2ab plus b square. Here a square is p tan theta whole square plus 2 into p tan theta into q secant theta plus q secant theta whole square minus p, here we have to take the bracket as there is negative, p secant theta whole square plus 2 into p secant theta into q tan theta plus q tan theta whole square. The next p tan theta whole square is p square tan square theta plus 2 into p into q 2pq 2pq tan theta secant theta plus q square secant square theta minus, here change the sign of each term as there is negative sign before the bracket, that becomes p square secant square theta plus 2pq secant theta tan theta secant theta tan theta. It is not plus, minus, because bracket is opened, so you must write minus 2pq secant theta tan theta minus q square tan square theta. Now bring p square and p square together. P square tan square theta minus p square secant square theta plus 2pq tan theta secant theta minus 2pq secant theta tan theta cancels, and bring q square secant square theta minus q square tan square theta together. Right, p q square secant square theta minus tan square theta. Here we have to prove that q square minus p square. Then here p square common is there, remove that outside. P square into tan square theta minus secant square theta. Here also q square secant square theta minus q square tan square theta equals, remove p square theta in the bracket. What you have to write? Here p square theta is common, remove that outside in the bracket. You will get tan square theta minus secant square theta. Then plus, here q square theta is common, plus q square theta into secant square theta minus tan square theta. Here we have to use the identity. You know that 1 plus tan square theta is secant square theta. So secant square theta minus tan square theta, 1 is equals to what? Secant square theta minus tan square theta. Here you can write q square into 1 plus q square into 1. Here what you have to take? 1 plus tan square theta is equals to secant square theta. Then tan square theta minus secant square theta is equals to 1 is to be transferred, that becomes minus 1. So here you write p square into minus 1. Then p square into minus 1 is minus p square plus q square. Q square into 1 is plus q square, which is equals to q square minus p square, which is equals to RHS. Therefore you write x square minus y square is equals to q square minus p square. Question number 86. Prove that secant theta minus cos theta into cosecant theta minus sin theta into tan theta plus cot theta is equals to 1. Here you note down what are given. In one bracket secant theta minus cos theta is there. Write that down. Secant LHS you write. LHS equals secant theta minus cos theta in one bracket. And here there are two brackets. In the flower bracket, two common brackets are there. In the first common bracket, what is there? Cosec theta minus sin theta. And in the other common bracket, tan theta plus cot theta plus cot theta. And for these two common bracket, there is one flower bracket. Equals, express secant theta as 1 by cos theta minus cos theta into cosec theta is 1 by sin theta minus write sin theta as it is. Write these two in the bracket. Next in the other bracket, write tan theta in terms of sin by cos. Sin theta by cos theta plus cot theta in terms of cos by sin. By sin theta equals, here you take the LCM cos theta, that is the numerator becomes 1 minus cos square theta cos theta means cos theta by 1. As the LCM is cos theta, 1 into cos theta is cos theta. Therefore, this cos theta is to be multiplied by cos theta. So, cos theta into cos theta is cos square theta. Write this in the bracket. Next, in the other bracket, here also take the LCM. What is the LCM? Sin theta. And this 1 remains as it is because the denominator is sin theta, minus sin theta is to be multiplied by sin theta and it becomes sin square theta. Write in the bracket into. Here the LCM is cos theta into sin theta. Cos theta into sin theta, and the numerator becomes sin theta into sin theta, sin square theta, plus cos theta into cos theta is cos square theta. Equals 1 minus cos square theta is sin square theta by, write this cos theta as cos theta only, next 1 minus cos square theta is 1 minus sin square theta is cos square theta by sin theta into the value of sin square theta plus cos square theta is 1 by, write this cos theta into sin theta as it is, into sin theta. Then you write the product of these three, sin square theta into cos square theta into 1 is sin square theta into cos square theta. Then cos theta into cos theta is cos square theta. Sin theta into sin theta is sin square theta. So you can cancel cos square theta, sin square theta, which is equals to 1. Therefore, secant theta minus cos theta in the flower bracket, cosecant theta minus sin theta into tan theta plus cot theta is equals to what? 1. 87 question. Prove that secant a plus tan a minus 1 by tan a minus secant a plus 1 equals 1 plus sin a by cos a. Write the LHS. LHS equals secant a plus tan a minus 1 by tan a minus secant a plus 1 equals express secant a in terms of cos, that is 1 by cos. Secant is 1 by cos a plus tan express in terms of sin by cos. Express sin in terms of sin by cos, that is sin a by cos a minus 1. In the denominator also express tan a as sin a by cos a minus secant a is 1 by cos a plus 1. Now you take the LCM on both the numerator and denominator. Here what is the LCM? LCM is cos A. Write as cos A, and the numerator here 1 remains 1 only, and sin A remains sin A only, and this 1 is to be multiplied by cos A. So you write 1 plus sin A minus cos A, because 1 means 1 by 1, as the LCM is cos A, 1 into cos A is cos A, therefore here also 1 into cos A. Next, in the denominator, again the LCM is cos A, right, cos A, and the denominator becomes sin A minus 1 plus 1 is to be multiplied by cos A, so multiply it by cos A. Then here cos A is in the denominator, you can cancel, and what is remaining in the numerator? 1 plus sin A minus cos A, 1 plus sin A minus cos A. Here sin A minus 1 plus cos A. Write LHS. LHS equals secant A plus tan A minus 1, secant A plus tan A minus 1 by tan A minus secant A plus 1 equals, here 1 is there, in the place of 1 let us take secant square minus tan square, because you know that 1 plus tan square A is secant square A. Therefore, by transferring this to the RHS, you will get 1 equals secant square A minus tan square A. Therefore, you write in the numerator, write secant plus tan A as it is, secant A plus tan A, minus in the place of 1 write secant square A minus secant square A minus tan A. Secant square A minus tan A by tan A minus secant A plus 1, tan A minus secant A plus 1 equals, here to take this in the bracket, and secant A plus tan A minus secant square A minus tan square A. Here 1 is equals to secant square A minus tan square A, that is equals to x. Here you got this in the form A square minus B square. Here 1 you have taken secant square A minus tan square A, and write this in the form of factor a minus b into a plus b. So you write secant a plus tan a into secant a minus tan a. Write this denominator as it is, tan a minus secant a plus 1 equals, here secant a plus tan a and secant a plus tan a, common factor is there. Write that in one bracket, secant a plus tan a, and here what is remaining in the first term, 1 minus, here it is outside, so what is remaining, secant a minus tan a, secant a minus tan a. By tan a minus secant a plus 1. Now write this in the first bracket, secant a plus tan a, here write 1 and open the bracket, minus secant a plus tan a, that by tan a minus secant a plus 1. Here observe these two, this and this, both of them are same, tan a minus secant a plus 1, tan a minus secant a plus 1 is there, so you can cancel this one. Then what is remaining, secant a plus tan a is remaining, and express in terms of secant in terms of 1 by cos a, tan in terms of sin a by cos a. Here both of them are having same denominator, then you write equals cos a, and the numerator becomes 1 plus sin a. You got RHS. Question number 88. Prove that sin theta by 1 minus cos theta plus tan theta by 1 plus cos theta is equals to cos theta plus secant theta into cosecant theta. Write the LHS. Equals sin theta by 1 minus cos theta plus tan theta by 1 plus cos theta. Now you take the LCM. LCM is the product of these two, that is 1 minus cos theta into 1 plus cos theta, 1 minus cos theta into 1 plus cos theta. Then in the numerator, sin theta into 1 plus cos theta plus tan theta into 1 minus cos theta. Right? Sin theta into 1 plus cos theta plus tan theta into 1 minus cos theta equals, here you multiply sin theta and 1 plus cos theta, that is sin theta into 1 is sin theta plus sin theta into cos theta is sin theta cos theta plus tan theta into 1 is tan theta minus tan theta into cos theta is tan theta cos theta. Then multiply 1 minus cos theta and 1 plus cos theta is 1 square minus cos square. 1 square minus cos square theta equals 1 square minus cos square theta is 1 minus cos square theta. Then you write sin theta plus sin theta into cos theta plus tan theta minus, write this tan theta as sin by cos. Sin theta by cos theta into cos theta. Then this sin cos theta cancels. Then you got in the denominator 1 minus cos square theta is sin square theta. Then you write sin theta plus sin theta cos theta plus tan theta minus sin theta. This sin theta minus sin theta plus sin theta cancels. Here in the denominator what is? Now you write sin theta cos theta by sin square theta plus tan theta by sin square theta. Tan theta by sin square theta. Write sin theta into cos theta by sin theta into sin theta plus express this sin theta as sin by cos. Sin theta by cos theta into, write this as 1 by sin square theta equals sin theta cancels, cos by sin you got, that is cot theta, plus again here into 1 by sin square theta can be written as 1 by sin theta into sin theta. This is tan theta by sin square theta. Here sin theta cancels, cos by sin is cot theta plus sin theta cancels. So you got, this is 1 by cos, its reciprocal is secant, and 1 by sin, its reciprocal is cosecant. Secant theta into cosecant theta, which is RHS. You got cot theta in plus secant theta into cosecant theta. Therefore sin theta by 1 minus cos theta plus tan theta by 1 plus cos theta is equals to cot theta plus secant theta into cosecant theta. Now take question number 89. Prove that tan A minus sin A by tan A plus sin A equals secant A minus 1 by secant A plus 1. Write LHS. LHS equals tan A minus sin A by tan A plus sin A. equals express tan A in terms of sin by cos. Right, sin A by cos A. In the place of tan A, write sin A by cos A minus sin A. In the denominator also write tan A as sin by cos. Sin A by cos A minus sin A plus sin A. Tan A minus sin A by cos A minus sin A. Tan A plus sin A is sin A by cos A plus sin A. Now here you can remove sin A as a common because both the term is having sin A. Here both the terms are having sin A. Then you write sin A outside in the bracket. Here what is remaining? Sin A is outside means 1 by cos A is remaining minus here sin A is outside the bracket. Here you have to write 1. You know that sin A into 1 by cos A is sin A by cos A and sin A into 1 is minus sin A. Sin A into minus 1 is minus sin A. Here also remove sin A common. Write that outside the bracket. Sin A into here also 1 by cos A plus 1. In the next step, cancel this sin A and sin A. Numerator and denominator are having sin A, so you can cancel them. Now write it as 1 by cos A is secant A minus 1. Here also 1 by cos A is secant A plus 1. You got the RHS. Secant A minus 1 by secant A plus 1. So you write this is equals to RHS. Therefore you can write tan A minus sin A by tan A plus sin A is equals to secant A minus 1 by secant A plus 1. Right? Therefore tan A minus sin A by tan A plus sin A equals secant A minus 1 by secant A plus 1. Question number 90. Prove that sin A plus cosec A whole square plus cos A plus secant A whole square equals 7 plus tan square A plus cot square A. Then you write the LHS. What is that LHS? LHS is sin A plus cosec A whole square plus cos A plus secant A whole square equals expand both sin A plus cosec A whole square and cos A plus secant A whole square by using the identity A plus B the whole square equals A square plus 2AB plus B square. Here A is sin A, so A square is sin square A. You write sin square A plus 2AB is 2 into sin A into cosec A plus B square. B square is cosec square A. Here A is cos A square is cos square A. 2AB is 2 into cos A into secant A plus secant square A. Now sin square A is there. Here cos square A is there. You know that sin square A plus cos square A is equals to 1. Bring them together. Equals sin square A plus cos square A. You can write this sum 1 in the next step. Next 2 sin A into cosec A is there. You know that sin A and cosec A are the reciprocal of each other. Here cosec A is 1 by sin A. That is sin A into cosec A. You know in multiple choice question and 1 marks question, you got that what is the value of sin A into cosec A. Sin A into cosec A is always equals to 1 as they are the reciprocals of each other. That is sin A into cosec A, it becomes sin A into 1 by sin A cancels each other. So directly you can cancel sin A into cosec A as they are the reciprocals of each other. Then you write 2 here. 2 plus write cosec square A. You know that 1 plus cot square A is cosec square A. So in this place you can write 1 plus cot square A. Cosec square A is what? 1 plus cot square A. Why you have to write? We have to express the RHS in terms of 7 plus tan square A plus cot square A. Here cot square A is there. So no necessity of cosec square A. Therefore in the place of cosec square A, write 1 plus cot square A. Plus this one we have taken here. Here also cos A and secant A cancels each other. Then you will get 2 plus secant square A. Secant square A you can write 1 plus tan square A equals sin square A plus cos square A is 1 plus 2 plus 1 is 3. Here 2 plus 1 plus 2 plus 1. It becomes 6. 6 plus tan square A you write first. Tan square A plus cot square A equals 6 plus 1 is 7 plus tan square A plus cot square A. You got the RHS which is equals to RHS. Therefore you can write sin A plus cosec A whole square plus cos A plus secant A whole square equals what? 7 plus tan square A plus cot square A. Question number 91. Prove that secant theta into 1 minus sin theta into secant theta plus tan theta is equals to 1. Write the LHS. Write the LHS. LHS equals secant theta into 1 minus sin theta into secant theta plus tan theta. Then you multiply secant theta and 1 minus sin theta. Secant theta into 1 is secant theta minus secant theta into sin theta is secant theta sin theta into secant theta plus tan theta equals, write this secant theta as it is minus, you can write secant theta as sin theta. Take the secant theta to the denominator, it becomes cos theta. So secant theta into sin theta is sin theta by cos theta into, write secant theta plus tan theta equals secant theta minus sin by cos is tan into, write this secant theta plus tan theta as it is. Then you write secant theta minus theta tan theta into secant theta plus tan theta. You can use the identity a minus b into a plus b, which is a square minus b square. So it is secant square theta minus tan square theta. secant square theta minus sin square theta, tan square theta, secant square theta minus tan square theta. Now you express secant square theta in terms of tan, that is 1 plus tan square theta minus tan square theta. Secant square theta is 1 plus tan square theta, and you write this minus tan square theta. Tan square theta cancels. It is remaining only 1, which is equals to RHS. Therefore, here you write secant theta into 1 minus sin theta, secant theta plus tan theta is equals to 1. Secant theta into 1 minus sin theta into secant theta plus tan theta is equals to 1. Question number 92. Prove that cosec A into 1 minus cos A into cosec A plus cot A is equals to 1. Same type of question. 91 and 92 are same types of questions. Write the LHS. LHS equals cosec A into 1 minus cos A cosec A into 1 minus cos A into cosec A plus cot A equals, again you multiply cosec A by 1 plus 1 minus cos A. Find the product of these two. So cosec A into 1 is cosec A minus cosec A into cos A is cosec A into cos A. Write this cosec A into cosec A plus cot A as it is. Cosec A plus cot A. In the next step, here you must write this in the bracket. Here cosec A you write cosec A only minus you write it as cos by sin. Cosec is the reciprocal of sin, then you can write cos A. Take this cosec to the denominator, it becomes sin. Cosec A into cos A means cos A by sin A. Write this cosec A plus cot A as it is. Plus cot A equals, it becomes cosec A minus cot A. Cosec A minus cot A, because cos by sin is cot. Write this cosec A plus cot A as it is plus cot A. Again you got it in the form A minus B into A plus B, which is equals to A square minus B square, that is cosec square A minus cot square A. Right, cosec square A minus cot square A equals, here you can express cosec square A as 1 plus cot square A. 1 plus cot square A is equals to cosec square A. So cosec square A is equals to what? 1 plus cot square A, and you write minus cot square A as it is. You can cancel this cot square A minus cot square A, then what is remaining? 1. Therefore, let us write cosec A into 1 minus cos A into cosec A plus cot A is equals to 1. Cosec A into 1 minus cos A into cosec A plus cot A is equals to 1. Question number 93. Prove that cosec A minus sin A into secant A minus cos A is equals to 1 by tan A plus cot A. Here you take LHS and get one result, and take RHS and get the same result. Then equate both, and then you will get this is equals to this one. So in the first case you take LHS equals cosec A minus sin A into secant A minus cos A equals, here you write cosec A as 1 by cos. You know that cosec is the reciprocal of sin is the reciprocal of cosec. So you write cosec A is 1 by sin A minus sin A as sin A only. Then here write secant A. You know that secant A is the reciprocal of cos. Then you write secant A as 1 by cos A minus cos A equals, here you take the LCM. What is the LCM? The LCM is sin A. Then 1 remains as it is, 1 sin A into sin A, sin square A. Write in the bracket. Next, here the LCM is cos A and the numerator becomes 1 minus cos square A. Write this 1 as it is. 1 minus cos A into cos A is cos square A. Equals 1 minus sin square A is cos square A. Write this sin A as it is into 1 minus cos square A is sin square A, and write cos A as it is. Here you can have cos square A is cos A into cos A by sin A. Sin square A is sin A into sin A by cos A. Here you can cancel cos A and sin A as it is a product. Now what is remaining? Cos A and sin A are remaining in the numerator and denominator 1. So you can take cos A into sin A, which is considered as 1. Now you take the RHS 1 by tan A plus cot A, right? 1 by tan A plus cot A equals, write 1 as it is and express tan A in terms of sin A by cos A, sin A by cos A plus cos A by sin A. That equals 1 by, here you take the LCM. LCM is cos A into sin A by it. Then it becomes sin A into sin A plus cos A into cos A. Sin A plus sin A, sin A into sin A is sin square A plus cos square A. And here you know that sin square A plus cos square A is 1. 1 by 1 cos A into sin A, which is equals to 1 into, take the reciprocal of this one, cos A into sin A by 1, that equals cos A into sin A. You got the same result for this also. Therefore you can consider it as 2 from first and second. From first and second you can write, what is that, cosec A minus sin A into secant A minus cos A is equals to 1 by tan A plus cot A is equals to 1 by tan A plus cot A, which is equals to what, cos A into sin A. Cos A into sin A. Then question number 94, prove that whole root 1 plus cos A by 1 minus cos A is equals to cosec A plus cot A. Then you write LHS. LHS equals whole root 1 plus cos A by 1 minus cos A. Then here 1 minus cos A is there. Multiply both numerator and denominator by 1 plus cos A. Right, 1 plus cos A by 1 minus cos A into 1 plus cos A by 1 plus cos A. Here what we have done? We multiplied 1 plus cos A and divide 1 plus cos A. Both numerator and denominators are multiplied by 1 plus cos A equals 1 plus cos A into 1 plus cos A is 1 plus cos A whole square. By 1 minus cos A into 1 plus cos A is 1 square minus cos square A. That is, we have to use the identity A minus B into A plus B, which is equals to A square minus B square. So the product of 1 minus cos A and 1 plus cos A is 1 square minus cos square. 1 square minus cos square A. Then whole root, write that 1 plus cos A whole square as it is by write 1 square as 1 minus cos square A. In the next step, write that 1 plus cos A whole square as it is. Then 1 minus cos square A is sin square A. Here you got square and square. Then this square and this root cancels. If you take the root, the square becomes cancelled. So that you can write, remove the root and square. What is that? 1 plus cos A by sin A is remaining. Here root of 1 plus cos A whole square by sin square A is 1 plus cos A by sin A. Here square and root cancels, equals. Separate 1 by sin A and cos A by sin A. Write this sin A below 1 and also below cos A. 1 by sin A plus cos A by sin A. 1 by sin A is cosec A plus cos by sin is cot A, which is equals to RHS. Therefore, you can take whole root. What is the question? Whole root 1 plus cos A by 1 minus cos A is equals to cosec A plus cot A. Whole root 1 plus cos A by 1 minus cos A is equals to cosec A plus cot A. Question number 95. Prove that whole root 1 plus sin A by 1 minus sin A equals secant A plus tan A. This is same as the 94th question. Here LHS equals whole root 1 plus sin A by 1 minus sin A. Write 1 plus sin A by 1 minus sin A as it is, and multiply both numerator and denominator. Here minus is there. Multiply both numerator and denominator by 1 plus sin A. 1 plus sin A by 1 plus sin A equals whole root 1 plus sin A into 1 plus sin A is 1 plus sin A whole square. 1 plus sin A whole square, and write 1 minus sin A into 1 plus sin A. Here you can use the identity A square minus B square, that is 1 A minus B into A plus B is equals to A square minus B square, and the product of 1 minus sin A and 1 plus sin A becomes 1 square minus sin square. Sin square A. 1 minus sin A into 1 plus sin A is 1 square minus sin square, as these two are as a product of A minus B and A plus B. Then equals, write the numerator 1 plus sin A whole square as it is, and write 1 square as 1. This is 1 minus sin square A. Now here whole root 1 plus sin A whole square by 1 minus sin square A is there. Write the numerator as it is. 1 plus sin A whole square. 1 minus sin square A is cos square A. Cos square A. Here it is whole root cos square A. Then you can cancel the square and root. So if you take the root, the square cancels, equals, write 1 plus sin A by cos A. Here root and square are cancelled. Then you separate. Write it as 1 by cos A plus sin A by cos A. 1 by cos A plus sin A by cos A. 1 by cos A is secant A plus sin by cos is tan A, which is equals to RHS. Therefore, here what you got? Therefore, you write whole root 1 plus sin A by 1 minus sin A is equals to what? Secant A plus tan A. Question number 96. Prove that secant A minus cos A into cot A plus tan A is equals to tan A into secant A. Write the LHS equals secant A minus cos A into cot A plus tan A equals, here you write secant A as 1 by cos. Cos and secant are reciprocal of each other. You write it as 1 by cos A minus cos A into cot A. Cot A is cos by sin. Cos A by sin A plus tan is sin A by cos A equals, take the LCM. Here the LCM is cos. Write it as cos A, and you write 1 as it is. 1 minus cos A into cos A is cos square A. Then here the LCM is the product of this sin A and cos A. You write the LCM sin A into cos A. You can write the bracket also. Now cos A must be multiplied by cos A, that becomes cos square A, and sin A must be multiplied by sin A, so that becomes sin square A. So write cos A into cos A is cos square A plus sin A into sin A is sin square A. Here the LCM is sin A into cos A, the product of sin A and cos A. So you must multiply cos A by cos A and sin A by this sin A. So you got cos square A plus sin square A by sin A into cos A. Then 1 minus cos square A is sin square A by cos A into cos square A plus sin square A is 1. Write sin A into cos A equals, write sin square A as sin A into sin A, sin A into sin A and write the denominator as it is. By cos A into sin A into cos A. Now you can cancel sin A and sin A, and sin by cos is tan. Sin by cos is tan. Write that as tan A, and 1 by cos is secant. Tan A into secant A is the RHS. Here you got tan A into secant A. Therefore you write secant A minus cos A into cot A plus tan A is equals to tan A into cos A. Secant A minus cos A into cot A plus tan A equals tan A into secant A. Now let us take question number 97. Prove that cosec A minus sin A into tan A plus cot A equals cot A into cosec A. It is same as the question number 96. Write the LHS. LHS equals cosec A minus sin A, cosec A minus sin A into tan A plus cot A equals express cosec A as 1 by sin A. Write minus sin A as it is. Into express tan A plus cot A in terms of sin and cos. Tan A is sin by cos, that is sin A by cos A plus cot A is cot A by sin A. Here you take the LCM. LCM is sin. Sin A is the LCM. Write this one as it is. 1 minus sin A into sin A. Sin A into sin A is sin square A. So you got 1 minus sin square A into, here you take the LCM. LCM is cos A into sin A. Then sin A must be multiplied by sin A, sin square A, plus cos A must be multiplied by cos A, that is cos square A. Equals 1 minus sin square A is cos square A. Write sin A as it is. Into Sin square A plus cos square A is 1. 1 by cos A into sin A. Then you write cos square A as cos A into cos A. Cos A into cos A is cos square A by, you can leave this 1 into 1 is same as cos A into cos A. Then you write sin A into cos A into sin A. Cos A cancels, or you cancel cos A. Cos by sin is cot A, and 1 by sin is cosec. So you got cot A into cosec A, which is equals to RHS. So you got that cosec A minus sin A into tan A plus cot A is equals to cot A into cosec A. Cosec A minus sin A into tan A plus cot A is equals cot A into cosec A. Question number 98. If tan theta is equals to root 3, then find the value of 4 sin theta minus cos theta minus 1 by 4 sin theta plus cos theta plus 1. Here you take the given, what is given? Tan theta is equals to root 3. Here we have to find the value of theta first. How will you get the value of theta? You must know tan how much degree is equals to root 30. Tan 60 degree. Tan 60 degree is equals to what? Root 30. Therefore, theta is equals to what? 60 degree. Therefore, you write theta is equals to 60 degree. By using this theta, by using that 60 degree, you can get the value of the 4 sin theta minus cos theta minus 1 by 4 sin theta plus cos theta plus 1. Write that 4 sin theta minus cos theta minus 1 by 4 sin theta plus cos theta plus 1 equals, here 4 sin theta means 4 sin theta equals what? 60 degree. So you write 4 sin theta is 4 sin 60 degree plus minus cos theta is cos 60 degree. Minus 1, right, as it is, by 4 sin theta is 4 sin 60 degree minus, this is plus cos 60 degree plus 1 equals 4, you write 4. What is the value of sin 60? Sin 60 is root 3 by 2. Sin 60 is root 3 by 2. Root 3 by 2 minus minus cos 60. Cos 60 is 1 by 2. Minus 1. You write minus 1 as it is. Minus 1. Then 4. Again sin 60 is root 3 by 2. Minus cos 60 is 1 by 2. It is not minus, it is plus. Plus 1 by 2 plus 1. Now here 2 are there, here also 2 are there. You can take the LCM. In the numerator, the LCM is 2. LCM is 2. Write 4 root 3 as it is, minus 1 also as it is. Why you have to write as it is? Because the denominators are 2. And this minus 1 is to be multiplied by 2. That is minus 1 into 2 is minus 2. Here also the LCM is 2. Write the numerator 4 root 3 as it is, plus 1 as it is. This 1 should be multiplied by 2 plus 2. You can cancel this 2 and this 2. That equals what is remaining in the numerator? 4 root 3 minus 3. In the denominator 4 root 3 plus 3. Plus 3. Here you got 4 root 3 minus 3 by 4 root 3 plus 3. So if tan theta is equals to root 3, then what is the value of 4 sin theta minus cos theta minus 1 by 4 sin theta plus cos theta plus 1 is 4 root 3 minus 3 by 4 root 3 plus 3. You can rationalize the denominator by multiplying 4 root 3 minus 3 to both numerator and denominator. Question number 99. Evaluate 2 cos 90 degree minus 30 degree plus tan 45 degree minus root 3 cosec 60 degree by root 3 secant 30 degree plus 2 cos 60 degree plus cot 45 degree. Then you write that one. 2 cos 90 degree minus 30 degree plus tan 45 degree minus root 3 cosec 60 degree by root 3 secant 30 degree secant 30 degree plus 2 cos 60 degree minus cot 45 degree. Cot 45 degree equals write 2 as it is. Cos 90 minus 30 is cos 60. What is the value of cos 60? Cos 60 is 1 by 2. Cos 60 is 1 by 2 plus you write tan 45. Tan 45 is 1 minus root 3, you write root 3 only. Cosec 60 degree. Sin 60 is root 3 by 2. Cosec 60 is 2 by root 3. Right? 2 by root 3. Cosec 60 is 2 by root 3. Then root 3 into secant 30 degree. Write root 3 as it is. Secant 30. Cos 30 is root 3 by 2. Secant 30 is 2 by root 3. Plus 1 minus plus 2 cos 60 degree is there. 2 cos 60 degree is 1 by 2 minus cot 45 is 1 equals you can cancel 2. So here what is remaining? 1. Right, 1. Then plus 1. Root 3 cancels. Here what is remaining? 2 minus 2. Here secant 30 is 2 by root 3. So you write root 3 cancels. 2 is remaining here. 2. Then you write plus. 2 cancels. 1. Then you write this minus 1. That equals 1 plus 1 minus 2 is 1 plus 1 is 2 minus 2, and here 2 plus 1 is 3. 3 minus 1 is 2. 2 minus 2 is 0. Got equals 0 by 2. That is equals to 0. So you got that 2 cos 90 minus 30 degree plus tan 45 degree minus root 3 cosec 60 degree root 3 secant 30 degree plus 2 cos 60 degree plus cot 45 degree is equals to 0. Equals 0. Question number 100. It is the last question of the trigonometric LBA. Prove that cos cube theta plus sin cube theta by cos theta plus sin theta plus cos cube theta minus sin cube theta by cos theta minus sin theta is equals to 2. Now let us write the LHS. LHS equals cos cube theta plus sin cube theta by cos theta plus sin theta plus sin theta plus cos cube theta minus sin cube theta. By cos theta minus sin theta. Equals express this cos cube theta plus sin cube theta as a product of two factors. You know the factors of a cube plus b cube, a cube plus b cube and a cube minus b cube. What are the factors of a cube plus b cube? The factors of a cube plus b cube are a plus b into a square minus ab plus b square, and the factors of a cube minus b cube are a minus b into a square plus ab plus b square. Here what are the factors of sin cube, cos cube theta plus sin cube theta? Equals, write the factors of cos cube theta plus sin cube theta. What are the factors of cos cube theta plus sin cube theta? First factor is cos theta plus sin theta, and the other factor is a square plus minus ab plus b square, that is cos square theta minus cos theta sin theta plus sin square theta plus sin square theta, and write this cos theta plus sin theta as it is. Then you write this plus, write the factors of cos cube minus sin cube. First factor is cos theta minus sin theta, and the second factor is cos square theta. Here minus is there, here plus cos theta sin theta plus sin square theta, that by cos theta sin theta, cos theta minus sin theta, equals, here you can cancel cos theta plus sin theta, cos theta plus sin theta, and bring cos square theta plus sin square theta together. Cos square theta plus sin square theta minus cos theta into sin theta. Here you write plus, here you can cancel these two, cos theta minus sin theta and cos theta minus sin theta cancels. Here what is remaining, bring this cos square theta plus sin square theta together. Cos square theta plus sin square theta plus cos theta sin theta. Here you got this much and here you got this much, as these two are and these two are cancelled. Now cos square theta plus cos square sin square theta is 1, and cos theta minus cos theta sin theta, and this plus cos theta sin theta cancels. You can cancel these two, and this is equals to what? Cos square theta plus sin square theta, that is also 1. 1 plus 1 equals 2. So you got that cos cube theta plus sin cube theta by cos theta plus sin theta plus cos cube theta minus sin cube theta by cos theta minus sin theta is equals to 2. So you write cos cube theta plus sin cube theta by cos theta plus sin theta plus cos cube theta minus sin cube theta by cos theta minus sin theta, which is equals to what? 2.